All right, welcome back. Let's check our answers and finish up those last few problems if you got stuck on them on this worksheet, right? That worksheet, work out of the book, uh, the lesson 2.2.2. Okay, I saved C for you, and basically what it was is you were trying to figure out the total number of square feet in that figure two different ways. Well, we had already in A figured out all of the shaded squares, right? And that ended up being 20 square feet. And we had figured out all of the non-shaded squares, and that ended up being 29 square feet. So one way is we just add them. Either they're shaded or not, right? That's covering the whole thing. So 20 plus 29 is 49 square feet. And remember, you can write square feet like that if you want. Feet to the second power. To the second power is squared. That's one way. Another way is we could just treat this entire picture, entire square, as one big grid that is 7 rows of 7 or 7 columns of 7, right? And how do you get the area of a square like that? It's 7 squared. 7 feet squared equals 49 square feet. Those are two different ways that you could get the area of that shape. All right. Now, we left the explain part on 2-35 about Hector measuring his desk with quarters. And basically, how I kind of want to explain is, yeah, he can get a good estimate, but he can't get exact because those circles do not what they call tessellate. Tessellate is when things fit together perfectly and there's no gaps and no overlaps. Okay, squares are like that. You can stack rectangles like that. You can go to those pattern blocks like we had in that last assignment, right? There's a triangle and a trapezoid, and you can fill every gap by putting these. And sometimes you see that on tiled floors, right? Tiled floors cover up the entire floor, right? So some things tessellate, they fit together well. Some things don't. Circles just, they don't fit, right? You can estimate, you can't get exact. That's one way of explaining it. That's a long-winded way. I would hate to write that whole thing, right? All right, 2-37, we left that, right? Oh, how could you do that? One of the ways I thought you could get 14 with these numbers is 14 I recognize as a multiple of what? It's a multiple of 7. Okay, I don't know if that's being a football fan and only 2 touchdowns is 14 points or what. 2 touchdowns with extra points. Used to be that's all they ever did is kick extra points. I don't know if you know that 2 point conversion used to be allowed in college but not pros till fairly recently. So it used to be 7 or 6 if they missed the extra point. Now they can get 8 if they really want to get that extra. Anyway, a multiple of 7, so I know 2 times 7 is 14. So if I can do the 3 and the 4 and make a 7, now, if I left it like this, I would not get 14. Remember, the order of operations says you have to multiply before you add or subtract. But what takes cuts in front of everything? The parentheses. So if I put parentheses around a 3 plus 4, I have to add first, right? I have to do what's in the parentheses first. Then I go 2 times 7, 14. That's one way of doing it, okay? If you found other ways, share it with me. I know there are other ways, and I think it would be kind of cool to see. I already know at least one other way, right? I could get to 12 by doing a 3 times 4, and then when I get done, adding. Now, I could put that in parentheses to make sure I do it first, but even if I didn't, I would multiply before I add. So I have 3 times 4, and really, I can have the 2 plus out here and do 3 times 4 here, and still I'm going to multiply before I add. So 3 times 4 is 12, and 2 plus 12 is 14. That's another way. At least two different ways. On to 237. Remember, that was the temperature for Honolulu, Hawaii in December of 2009. Crazy how close these are together. I've heard that Hawaii has the most consistent temperatures in the smallest range of almost any place on Earth. Why do you think that is? Science question for you, Matt. Well, remember why I think you've heard me say before that Windsor is pretty lucky we have what's called a temperate climate. That means it doesn't get too hot and it doesn't get too cold. And even on our hottest days, it cools down at night. Why? Well, it's because we live relatively close to the Pacific Ocean. Big, huge body of water. And air temperature does not affect water temperature very much, especially if that water is deep like the Pacific Ocean. So where's Hawaii located? Out in the middle of the ocean, right? So because of that, the temperature will not change much from day to night, and it won't change too much from day to day. Okay, so here we have that range. Remember, 84 to 79. That's only a range of 5 degrees. I think a dot plot would be the easiest here, and you could do dots or even X's. So if we were going to do this, I'm going 83, 83, 81, 82. I'm going 83, 83, 81, 82. Then I'm going 80, 83, 81, 80, 83, 81, 82, 79, 83, 82, 79, 83, 84, 82, 81, 81, 84, 82, 81, 81, 80, 81. And sorry, you got to sit through me doing this entire thing. But I think it's kind of good for you to see, once you get going on these things, how long does it really take to finish? It's a good thing. You don't want to say this homework took me an hour if the video doing the homework only took 15 minutes, right? Now we have 2 videos showing this. Oh, I do have a 78 in there. Uh-oh, got to squeeze that 78 in there now. Okay, 80, 84, and 70, 82, 82, 81, and 83. Boom, all done. That's a dot plot, right? Also called a line plot sometimes. There's my Wheel of Fortune hint for you. Okay, 15 times what is 90? You remember fact families, but wait, there's more. If that's true, division. 90 divided by 15 should equal what we're talking about. And if I count by 15s, 15 and 15 is 30. So every 2 is going to make a 30 because I know 30 fits in there. So 2, 4 is 60, 6. Okay, I could double check that and go multiply if I want. 6 times what? 6 5s is 30. 6 10s is 60. And 60 and 30 makes 90. Okay, 90 over what equals 18? Well, if 90 divided by this equals 18, then this times that should, right? 18 times what? Or I can also say 90 divided by this is that, 90 divided by that is this, right? Fact family. 90 divided by 18 equals what? And if I do 18s, I'm going to guess, let's guess 4, right? Purposely guessing a wrong number. I know what it is, because there's a trick. 32 and 4 plus 3 is 7. That's not enough. I'm going to try another one. I'm trying 5. All right, and 5 is what works. Now, when I said there's a trick, what was my trick? When you multiply a number by 5, it's like taking half that number and multiply it by 10. So 5 times 18 is the same as half of 18 times 10. What's half of 18? 9. And 9 times 10. Okay, cool little trick. Here we are again. 6 times what is 96? Well, 96 divided by 6 is what? Right? So we can just divide, and we could do the standard algorithm this time if you want. 6 times what? 6 goes into 9. How many times? 1. I multiply, I subtract, I bring down the next number, and 6 goes into 36. So this time, 6 times 16 is 96. 16 is the missing number. Okay? 6 was the missing number. 5 was the missing number. Again, put big box around the problem, little box around around the answer. And I'm going to try to include all the work in the big box, right? Even if it ends up being a box shaped like Utah or someone with a thumbs up or something, right? All right, this divided by 11 equals 13. Well, that means this divided by 13 is 11. But wait, there's more, right? That means 11 times 13 equals this. What is 11 times 13? Remember the trick with 11s? Oh, you just repeat, but it's not 13, 13. That only works with single digits, right, up to 9. But here, 1 times 13 is 13. Placeholder, 1 times 13 is 13. Kind of cool little trick here, right? When you're multiplying this, that's the first number, that's the last number, and the middle number is this plus this. What does that mean? 1, 3, 1 plus 3. All right, what if it was 15 times 11? Well, the first number is 1, the last number is 5, and the middle number is 1 plus 5. Cool trick. All right, anyway, so we figured out 11 times 13 is 143. So 143 was the missing number there. Boom, mic drop. I'm done. I'm out of here. See you later.